Hi. Today we are going to focus on what is the multiple linear regression equation. This is a linear equation where more than two variables, that means more than two independent variables, are impacting a dependent variable. Okay, the dependent variable is also called as outcome or target variable. Okay, now the equation of a multiple regression equation becomes y equal to b0, that is constant, plus b1 x1 plus b2 x2 plus b3 x3 and so on. This multiple regression equation is basically used to predict the dependent variable. That's why it is used in the prediction analysis or predictive analysis. Now let's see the whole process. First of all, we have to find out all the factors. Okay, now these are independent factors which are impacting the dependent variable, okay, or the outcome. Run the whole process of regression and try to find out what are the coefficients of these variables as well as the constant. By this, you will get a regression equation. Now, not necessarily that every factor impacts outcome or impact the dependent variable up to extent. So we have to find out those factors which are statistically important. The factors which are not so important, you can eliminate those, because our objective should be we have to find out a outcome of the dependent variable with the help of minimum number of independent variables. By this, we can actually control those variables and we can predict the output in a better way. So after removing those non so important variables, we can rerun the regression equation and check whether there are any more independent variable which are not so important. At the end, when you reach to a situation where all the variables are impacting a dependent variable significantly, we can call it as a finalization of a regression model. So here our objective is to create a regression model which will help you to predict the dependent variable more accurately. Now let's see how to execute this process. Now we will see how a linear regression model, which is basically using multiple variables, is calculated with the help of Excel. Now look at this table. This table is about a box office collection of few movies which are released in the year of 2013, 14 and 15 in India. The data says that the date of release, the movie name, the genre, number of leads male, number of leads female, a budget of the movie, YouTube views it received, YouTube likes it received, as well as YouTube dislikes it received. Okay. Apart from that, it also has a gender of a director, whether it's a female director or the male director. And at the end, it also has the box office collection. Now, you must have realized or analyzed from this table, which says that all these variables, okay, we can easily calculate the box office collection is a dependent variable and it depended on multiple factors like what is the genre, what are the number of leads, a number of female leads, what is the budget, etc., etc. So let's try to create a regression model with the help of these variables. Okay. Now always remember that in case of linear regression model, it always consider the numerical values. If you have a non-numerical value or the textual value like genre or movie name or the gender of director, it will not able to calculate the relationship between the dependent and independent variable. Okay. In conclusion, it only includes the numerical values while calculating the regression equation. Okay. Now let's work it on. To calculate a regression equation, you should install the add-in, which is the Excel add-in, which is generally available in all variations of Excel. For that, you have to just go to your file option and click on add-ins. Now after that, you have to click on to tab. So there is a tab called as data. Click on the data, and you will see on the right hand side here data analysis. Okay, this is only visible when you install a add-in pack. Okay, so click on the data analysis. It will give you multiple options like ANOVA, correlation, covariance, descriptive statistics, etc. One of the options is called as regression. So click on that, click on OK. It will ask you options. What is your input range? What is your output range? Okay. So let's see the input y range. Always remember that the input y range is basically the dependent variable. Okay. So we have to find out what is the input y range, which is our box office collection. Okay, so we'll select the column of box office collection, which is our dependent variable. So we'll select it completely. So there are 149 entries or sales in that. Okay, so 148 entries are there. Again, your input range is the range of all your independent variables. So as I said that we have to focus only on a numerical variables. Okay, so we'll select all the variables initially, and let's see which variables we can eliminate. So we can select number of leads, male, female, budget, YouTube views, likes and dislikes. Okay, so you can select multiple variables here. So collected till the last point. Okay, and then as our column has headings, we have included those in the this particular data points. Okay, so we'll click on the labels. If your data point has no labels, you can deselect this. Okay, I want the output range, so you have to go and select the output range where you want to have your output. I just wanted to do it here. Okay, so I will select that. And I also want to find out what are the residuals. I will tell you what are the residual means. Okay, and then simply if you want more information, you can click on other options. Otherwise, for basic calculation of regression model, this information is enough, because we also have a confidence level which is kept at 95%. Okay, and then we have not assumed that the constant is 0. We want the actual value of the constant. So click on OK. It will give me a summary output. Okay, so this is the output that I received after running a regression equation. So we'll see a few of the points here. We'll say multiple R, which is basically a correlation, which is 0.75, which indicates that it is a positive correlation, much stronger. Okay, the R square value is 0.56. Okay, there are much more information, you can go through it. Then there is a ANOVA table, which basically analysis of variance. You can refer to my another video to understand what is ANOVA. But the value of F is 1.62 raised to minus 23. So this is a significant value. Okay. Now we are more concerned about the coefficients. Okay. So let's see here. These are the coefficients of the variables. So here intercept, which is also called as a constant. The constant comes as minus 23, and these are the coefficients of different variables. The variables are number of leads. Here is 1.01. Number of leads female 10.04. Budget is 1.31. YouTube views is minus 4.1 raised to minus 6. And YouTube likes and YouTube dislikes. Okay, these are the coefficients. Okay, so if I put it into a regression equation, it says that y, which is a dependent variable, is equal to constant, that is 23, plus 1.01 number of leads, plus 10.04 number of leads female, plus 1.31 budget, minus 4.1 raised to minus 6 YouTube views, plus 0.004 minus 0.0009 YouTube dislikes. Okay, so this is my regression equation with the data that I have. Now look at much more important numbers which are called as a p-value. Okay, now this p-value is one of the important things which will help you to analyze whether the variable is important or not. So I hope you know the concept of p-value. Okay, and again the importance of value 0.05. Okay, so we say that if the p-value is less than 0.05, that means it has a statistically significant impact onto a dependent variable. Okay, so if you see here all these values of p, we can say that yes, the budget in lakhs and YouTube likes, these are the two values which are less than 0.05. This means that these values are much more important. These variables are much more important in predicting the dependent variable. Okay, other values are much higher than 0.05. So this also indicates that we can eliminate those variables and can focus on only two variables which are significantly impacting. In other cases, these are not significantly impacting the dependent variable. Okay, now let's see how these two variables impacted. So we'll eliminate other variables and we'll only focus on two variables, okay? Budget and YouTube likes. So for that, I want to rerun the equation. Okay, so let's see how to do it. So which are the two important variables? YouTube likes and budget. So we rerun the equation. Okay, we'll again go back to data analysis. Click on this. Again, we go for regression. Okay, our output range will be same because it's a box office collection. It's a dependent variable, but our input variable will be different. So our input variables will be budget and YouTube likes. Okay, so in a Excel, when you select the input range, it has to be two continuous columns. So that means I have to shift this column. Okay, so just cancel it. So I just cut this column here. Now I got these two columns adjacent with each other. Okay. Go to data analysis, regression. Okay. This is the input range. Now I select the output range, which are basically two variables that I want to study, budget and YouTube likes. Okay. Click on OK because rest of that, okay, output range will be okay somewhere here, and just click on OK. Fine. Now I got another output. Now if you see here, in previous case the value of R was 0.75, and with the revised equation I got a value of R 0.74. So there is not much difference in the correlation. Okay, and then what we have studied here is the coefficient, okay, and the p-value. Okay, so you can see here also the p-value is quite lesser than 0.05. Okay, and we have a revised coefficient that is for budget is 1.24 and YouTube likes is 0.0033. Okay, so in this case the equation becomes y equal to minus 7.65, okay, plus 1.24 budget, okay, plus 0.0033 into YouTube likes. So this is the revised equation. Okay, now what we had done, we have eliminated the unrequired variables which are not impacting the dependent variable much, and we shortlisted only two depending upon the p-value. So where the p-value is less than 0.05, we have selected those variables, because that is statistically significant for impact on a dependent variable. Okay, so this is the regression equation that you calculated. Okay, here we have selected two variables. You can select multiple variables. Okay, so instead of two, whenever the p value is lesser, you can select that variable. Or you want to say that yes, 0.013 is not so higher than 0.05, so you may want to add number of leads there. Okay, you can include this into the equation. That all depend upon what is the focus of a researcher. Okay, so this is the equation that you get. Okay, now there is another field that called as a residual. Okay, now what is my residual? Residual basically means a difference between the actual box office collection and the predicted box office collection. Okay, now how you predict it? You predicted it with the help of this equation. Okay, and then you see the value of box office collection here, which is predicted. Okay, here it is a predicted box office collection. So in this particular case, this is 127, and for the first movie. Okay, and the actual one here is 104. So the difference between 104 and 127 is 23. So this is called residual. So what is my residual? Residual means a difference between the actual collection and the predicted collection. That means the actual variable, dependent variable, and the predicted variable. That's called as the residual. So you can see the residual here. Okay. Now you can compare the residuals of two models. So this is model number 1 that we have done it with the two variables, and then you can see the residuals here. So if you can see here, the residuals are different because the equation here is different. Coefficients are different. Okay, I hope you got this concept of multiple linear regression equation where we use the value of p. If you have any doubt, please write in a comment and let me know.